This video, we're going to try some synthetic division. Okay, we have a couple problems set up. In this first one, we have a kind of a big, long polynomial divided by x minus 2. So the way we want to set this up is, instead of like our normal division like we learned in 3rd grade, it's going to have this opposite kind of L-looking shape like this, where normally it'd be flipped up. But this one we're going to take, if I were to set this equal to 0, x minus 2 equals 0, x would equal a positive 2. We're going to take a positive 2 and put it out here, right? That's like our divisor, okay? And then on the inside, I'm going to write out all the coefficients of my polynomial, okay? So for example, I have a 1, a negative 4, a 6, and a negative 4. A 1, negative 4, 6, and a negative 4. We'll get rid of that, okay? Then you're going to take your first one, and you're going to bring it down. I like to draw an arrow sometimes. I'm going to take a 1 like that. All right, on the bottom, you take those and you multiply by the number out front. So 1 times 2 is 2. And then these inside here, you're just going to add those numbers together. So negative 4 plus 2 is a negative 2. Negative 2 times 2 is a negative 4. 6 minus 4, or 6 plus a negative 4, if you want to think of it that way, is a 2. 2 times 2 is 4. And then the last one, negative 4 plus 4 is 0. So this tells us a few things. First off, this last number, this is going to tell us whether or not what we're dividing by, if that is or is not a factor. Because this is 0, this is going to be a factor. All right, I'll show you why here in just a second. But first off, we want to write our answer like this. This is going to be our number term, our x squared. And if we would have more, it'd be x to the third, x to the fourth, and so on. And so what I mean by this is we're going to say we have 1x squared, or I could just say x squared, minus 2x. And then our constant term, or our number, is just going to be a positive 2. Okay, so this polynomial divided by x minus 2 is going to equal x squared minus 2x plus 2. Now, I said I was going to get back to this remainder thing here in a little bit. Think if I were to take a number like, let's say 22. 22, and I were to divide that by 5. Okay, does 22 go, or does 5 go into 22 evenly? No, it does not. If I had 20 divided by 5, that would equal 4. That does go into it evenly. Or you could say it's 4.0. But here, 22 divided by 5 is and 2 divided by 5 is going to be 4/10. So I could say 4.4. All right, same idea is kind of going on here. Because this was a 0, and since this is a 0, this one is not going to have a remainder. However, if this would have been a different number, I would have had to take my remainder and divide it by whatever I was dividing by up here. Okay, just like over here, I could say this is actually the same thing as 4, and I'd have 2/5 left over, 2/5. That's kind of what we would do. In this next one, we're going to get an example where that happens, and you'll see what I mean by that. Okay, so let me get this erased. And then in the second one, there's another kind of tricky part about this, and notice that it's missing some exponents. It jumps from 5 to 2 and then down to my constant term. Whereas in my first one, it went 3, 2, 1, none. That's okay. This one's not okay. We have to fill in those missing spots with zeros, okay? So I'm going to take, again, if you set that equal to 0 over here, it's going to be x equals a positive 2. So I'll have the same one I'm divided by. That's okay. So again, we're going to have a 2 out front. And because this is a 5, all right, I have to kind of think through in my head. 5, 4, 3, 2. So I have the 5, I'm missing the 4, I'm missing the 3, and then I have the exponent of 2, so this is going to be a negative 38. And then I'm missing the 1, just the x, and then I do have the constant term of a 4. So if you kind of just double check, I always like to start with what my biggest exponent is and count down to 0. So 5, 4, 3, 2, 1, and 0. So I know that I have them all. All right, let's do the math here. Again, bring down this first one. This is going to be a 5. 5 times 2 is 10. 0 plus 10 is still 10. 10 times 2 is 20. 0 plus 20 is still 20. 20 times 2 is 40. Negative 38 plus 40 is a positive 2. 2 times 2 is 4. And then 0 plus 4 is still 4. And 4 times 2 is 8. And 4 plus 8 is 12. So this one does have a remainder because my last number is not a 0. All right, so again, if I were to think about this, this is my remainder. Maybe put an R there. And then my number, my x squared, x to the third, and x to the fourth. So the way you're going to write your answer on this one is going to be 5 x to the fourth. All right, and then plus 10x to the third plus 20x squared plus 2x plus 4, right? And then the way that I've seen this written probably most often is people put a little fraction bar here, and since it's positive, you could probably say plus. On top, you're going to put what you're left with, your remainder, and then on the bottom, you have to put what you were originally dividing by, which in this case is going to be x minus 2. Right, x minus 2. Just like, again, if I had 22 divided by 5, that example, this was 4 with a remainder of 2/5. So that's why you would say 2/5. Same thing here. You get your, this would be like my 4, right? And my remainder is what I'm left with over what I was originally dividing by. And this one I was dividing by x minus 2. So that's synthetic division. There's a couple nuances to it. Hopefully that's helpful for you. If it is, we'll see you in the next one.